Welcome to our first video on matrices. What is a matrix? This is a table. If we put numbers in square brackets, we have formed a matrix. The plural of a matrix, in other words, if you've got more than one matrix, would be matrices. Here is a matrix. We use capital letters, A, B and C, etc., to name the matrix. This matrix is capital D. Please note it's got square brackets around it and it's a formal thing. We generally don't actually have the labels on the matrix, but they are clearly inherent as part of the matrix. We use matrices to process really large amounts of data, and we're only going to work with generally small matrices, but in real life matrices can process really large amounts of data. Matrices is about rows and columns. Whenever we talk through this topic, we'll always talk about rows first and columns. Everything relates to rows and columns in that order. Rows and columns. This matrix here shows the rows and columns. This is row 2. Rows go across like in a theatre. Here there are 1, 2, 3, 8 rows. Columns, I think of columns as holding up buildings. Columns to me are vertical. Rows and columns. There's row 2 and column 3. We start from the top for the rows and we start from the left for the columns. These are the building blocks for matrices. The order of a matrix. The order of a matrix tells you about the size of the matrix. The order of a matrix is defined as the number of rows times the number of columns. We don't do the calculation, we just write down the number of rows, put in a multiplying symbol, and write down the number of columns. So the order is rows times columns. This matrix here has 8 rows and 3 columns. So therefore the matrix shown is an 8 by 4 matrix. We don't calculate the value. However, if you're asked to work out how many elements there are, this element here in row 2, column 3 is 19, is one of the elements. Of course, there's 8 rows times 4, there are 32 elements. The order of the matrix. This one is a row matrix. It only has one row. It does actually have 4 columns. Doesn't look like it, but it has one row. This matrix is called a column matrix. It has one column. Yes, there are 8 rows in it. Doesn't look like it, but this is a column matrix. A square matrix has exactly the same number of rows and columns, and of course looks like a square. Let's look at these particular ones, and you can actually record these. Matrix A, let's look at matrix A first. It is a square matrix. The number of rows equals the number of columns. Its order is 3 by 3. We write it as 3 times 3. There are 9 elements in our matrix. B. What type of matrix is B? B only has a column. It is a column matrix. There would be 1, 2, 3 rows and 1 column. The order is 3 by 1. We write it as 3 times 1. There are 3 elements in it. And you've spotted it. The next one is a row matrix. It only has 1 row, but it has 6 columns. The number of elements is 6. How do we record these? Capital A for matrices tells us it's an A matrix, and the actual elements in it, this one is actually in row number 2 and an element 3. So we call this a little a, lowercase a, with a subscript, which means smaller, written down to the right hand side, 2, 3. A, 2, 3. In this particular matrix here, we're going to write down the values of A1, 2, A2, 1, and A3, 3. Rows, columns. Row number 1, position number 2, the answer is 5. Column 2, row 1. Column 2, that's column 1. Column 2, first row number 1, pardon me, row 2. This is the second row. Second row, first column, the answer is -1. And 3, 3, row 3, 1, 2, 3, and column 3, the answer is 6. Draw a matrix for the network diagram shown below. This is going to show the connections. Our matrix will actually have 4 towns connected to 4 towns. Town 1 to 4, town 1 to 4, and we'll always go from in the rows and to in the columns. So if we look at town number 1 first example, we're going to look all the way across here from town 1 to the different other towns. Now town 1 is not connected round to itself, so town 1 not connected to itself. Town 1 is connected to town 2. Yes, there is one connection from town 1 to 2. This could be a road, it could be a gas pipeline or electricity supply, it could be a data connection. But nevertheless, town 1 is connected to town 2 by that one road. Town 1 to town 3. Town 1 is not connected at all to town 3. You could go via another way, but there is no direct connection. Town 1 to town 4. Town 1 to town 4, there are lots of connections that would make this through that way, series of connections, but there is no direct connection from town 1 to town 4. Town 2. Town 2 is it connected to town 1? Yes, we already identified that before. There is one connection. Town 2 is not connected to itself, and in fact, none of the other towns are actually connected to themselves by one connection. Okay, let's look at town 2. Town 2 to town 3. Town 2 to town 3, there is 2 direct connections. Town 2 to town 4, there is 1 direct connection. Town 3 to town 1. Oh, no direct connections. Town 3 to town 2. There are 2 direct connections. Town 3 to town 4. Town 3 to town 4. I can see 3 direct connections. And you may be able to complete the rest of them. You should also be able to notice that down this diagonal there is some symmetry happening. You might be able to pause the video and see if you can understand why this is actually a symmetrical matrix. The transpose of a matrix. To transpose a matrix is to swap the rows and the columns. So to transpose this matrix, this one is in 1, 1. So if I swap 1 with 1, that will remain the same. Position row number 1, column number 1. Let's look at this one. This number here is in row number 1, column 2. So it will become, swapping the 1 and the 2, it will be row 2, column number 1. It's been transposed. Let's try the next one. The next one is in row 2, column 1. So it will be in row 1, column 2. This element here is in row 2, column 2. The 2 and 2 will swap, so it will be in that position. Try the next one. Row 3, column 1 will become row 1, column 3. This number 6 is obviously going in the remaining place. The transpose of a matrix. You'll be able to do the transpose of a matrix by creating a matrix, pressing Menu, Matrix, Vector, Transpose. Let's have a look at our calculator now. In your calculator, as long as you're in a calculating screen, which I am already, you can go into here and ask to do a matrix. If you've got a 2 by 2, you could select that one, or a 1 by 2 or a 2 by 1. I'm going to select a matrix like this. I'm going to make mine a 3 by 2, and I can actually pop my matrix in there. Using my arrows, I can certainly work around mine, typing in some numbers, and if I press enter, I can clearly get an answer. We'll be able to add, subtract, multiply, do scalar multiplication, other operations. But first off, I'd like to do that transpose. I've typed in my matrix. I could go and type it again, but I'm going to use my arrow key to go back and get that one, and then press enter, and it comes down here. I want to first off do that transpose. Menu, matrix and vector is number 7, number 2 is to transpose, and it raises it to a small t. When I press enter, the transpose of the matrix is just as we've done. You should be able to type matrices in, and you should be able to play around them. We'll certainly learn how to work with those in a short while. Now we're going to ask you to go off to have a look at exercise 11A and 11B and do all the relevant questions. So where is 11A? Let's have a look at the first questions you're going to have a look at. You'll be asked to find the order, do the transpose. I think you could do that manually. You could do it with a calculator. Work out some information about matrices and also their elements. 11B is further down. 11B, again, this table gives you some information about some residents. You ought to construct a matrix to do that, talk about their orders, etc. And finally, you'll be asked to create some matrices from these particular diagrams. We'll get to 11C shortly. Thank you for your time. It's now a useful time to go off and actually have a look at exercise 11A and B. Thank you for watching this video.